Hello everyone, I am Snigdha Kakkar and this is my channel Accelerate AI Careers. Today I have brought a very interesting LeetCode problem 1011 capacity to ship packages within D days. This is one of the similar questions which I have solved previously, LeetCode 875, Cocoa Eating Banana. So if you want to try that question out first, you can try it out. These are on similar lines, almost similar questions, just different description. But the way of solving these two questions is almost same pattern. So now you have been given a weights array which has these kind of weights as shown in example 1 here, and you have been given a number days. So basically this days number is nothing but number of ships given to you. So you have been provided the number of ships, you have been provided the number of weights, and you have to find out the least weight capacity for a particular ship. All ships will have the same capacity, and the least weight capacity that can support all of these weights in these number of days. Basically, you have been given 5 ships. So divide these weights in those 5 ships. You have to decide that capacity, and that should be the least possible capacity. That's your output desired here. So, for example, here in this question, what could be the minimum weight capacity that you can assign to a ship? Suppose I assume that a ship of 5 kgs can be there, which can carry, and there could be 5 ships and they can carry everything. So let's check if my assumption is correct. If my ship's weight is 5 kgs, then 1 plus 2, 3, and 3 plus 3 is 6. So my first ship will carry only first 2 weights, because as soon as I add the third weight, the number of weights is 6, which is greater than the ship's capacity. So my first ship will carry first 2 weights. My second ship will carry only third weight, because as soon as I add the fourth weight, the sum amounts to 7 kgs, which is greater than the ship's capacity. Now my third ship will carry only this fourth weight. As soon as I add the next, the capacity is exceeded. And my fifth ship will carry only the next weight. So my rest of the weights are not carried. That's not the right result which is expected. So hence the capacity would be more than 5 kgs. Now you would ask me, using this brute force approach, I will keep on assuming a ship's capacity and checking throughout the array if that capacity is possible or not. And then also I will not be able to find whether that's the minimum capacity or there is a capacity possible which would be less than that and still be able to carry all the weights in these number of days. So what could be my approach here? If I use this brute force approach, it's basically nested for loops, and your time complexity in this scenario would be O of n square. But you can do better than that. So to do better than that, you have to find out what is your minima here, what is the minimum capacity that is needed. So if you see that you have a weight of 10 kgs as well. So if a ship has capacity less than 10 kgs, in such a scenario, none of the ships will be able to carry this weight, right? So the minimum capacity for a particular ship should be the maximum weight in the array, so that at least one ship can carry one weight. So let's assume that the minimum capacity is 10 kgs, because here the maximum weight is 10. Now what is the upper cap? What's the max capacity possible? So I need my ships to carry all these weights in these number of days or less than these number of days, right? So my maximum capacity for a ship would be sum of all these weights. I don't need a ship of more capacity than that, right? So I have my min capacity is maximum weight, maximum W, and my max capacity, my max cap is sum of all these W's. So I have a lower cap, I have an upper cap, and I have to find the least capacity possible. So to do that, I can use binary search. And the cocoa eating banana question also we solved using binary search. There also we were given an array of bananas and we had to find the optimum quantity of banana. So with using binary search, I will find a midpoint, and my midpoint would be L plus R divided by 2. And then I would use that to check if at that particular midpoint, is it possible to assume ship's capacity as that mid capacity, and then check if the number of ships is less than equal to this number of days. If yes, then you can return that as a result. But how do you know that there is no possible value less than that possible? So then you will update your right pointer, your upper cap to this, and then you will find another mid and another mid, and that ways you will get the most optimum capacity. But if say suppose that mid does not meet your requirements and your number of ships is not less than equal to these number of days for this midpoint, then you will increment your left pointer to mid plus 1. Otherwise, you will decrement your right pointer to mid minus 1. That's how binary search works. In this case, your time complexity would be, and you would say O of n log n, because you are anyways traversing through the entire array, so n, and log n for binary search. But that's not true here, because you have a min and max, you have a minimum cap and an upper cap. So your time complexity would be O of n, because you are traversing through the entire array, log of m, where your m is the midpoint. Why? Because you are not traversing through the entire array, but you are traversing through that midpoint, because you directly find the midpoint between left and right, and then after that you traverse through that midpoint only. You don't traverse the entire array. Now let's start coding it. So first of all, I will initialize my left pointer and right pointer, that is my minimum capacity and my maximum capacity. My minimum capacity would be my max of weights, so my max weights, and my upper cap or right pointer would be sum of weights. So now once I have this, I can also update my result. I will initialize my result with R, that is my upper cap, and I'll keep on reducing my result because I need the lowest possible capacity. Now after that, I would write my nested can ship function where I will pass the capacity which I obtained as a midpoint, and I will check if we can ship using that capacity. So here I will initialize my number of ships as 1. At least we will have one ship to send all the weights, right? And I'll also initialize my current cap, and my current cap would be initialized by cap which I pass here. And I'll keep on reducing my current cap by W. So for W in weights, and I'll move through the entire array. I'll traverse through the array, and I will check if I subtract my W from my current cap, is it negative or positive? If it is negative, that is, I cannot add this weight to the current ship. So I will have to increase the number of ships by 1. And also, I will have to reset my current cap for my new ship to my capacity which I have passed. Okay. But if this current cap minus W is not less than 0, it is greater than 0, then this weight W can be adjusted in current ship. So in that scenario, I will reduce my current ship's capacity by this W, because I have already used this W capacity. And finally, I will return my possibility whether the number of ships which I have obtained is less than equal to days or greater than days. If it is less than equal to days, then these number of ships at this particular capacity can take the weights, all the weights in the array, and all the conditions are met. But if this result is false, that is the number of ships required is greater than the given number of days, in such a scenario you have to find some other capacity. So this is your can ship function. After that, I will apply binary search. So while my lower limit is less than equal to my right limit, upper limit, that is, I have not traversed the entire range, and then I'll calculate the midpoint. Midpoint would be left pointer plus right pointer divided by 2. And then I will check if I can ship using this capacity which I obtained as a midpoint. So if the result is true, in such a scenario, I can ship at this point. So I will update my result as minimum of this result and this capacity. And I will also update my right pointer to cap minus 1. Because I have to find if there is any other lower capacity that is possible than this capacity cap, to see which can meet all the conditions, because I have to find the least possible capacity. Else, if can ship result is false, that is, you cannot ship at this capacity, you will increment your left pointer to cap plus 1. And then finally, you can return your result. So this is your entire code. Let's run it. It's accepted. Let's submit. So as you can see, our solution is doing quite well here. Now, if you have a better approach to solve this question, mention it in the comments. I would love to learn from you. Also, let me know, how did you find this solution? Was it easy, difficult? Was there any doubts you have right now? You can ask it in the comments. I'll be happy to resolve it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.